What's up, Mr. Getty? Yesterday, April 12th, 2018, the boys met up to make some boat prototypes. In this video, we're going to explain to you what we thought worked the best and why we made each prototype the way we made each prototype.
We wanted something on the simpler side for Prototype 1, but something that still utilized strategic and careful design choices to provide optimal stability and speed. The boat itself is a medium-sized rectangle. The bottom of the boat uses a V-shape to provide speed while also being stable. The V-shape helps cut through the water, allowing the boat to glide at higher speeds. This triangular shape results in less surface area compared to a square or rectangular bottom, therefore there is less drag. The hull slopes up slightly on the front and back of the boat, using triangular shapes to also create a sort of V on the front and the back. The V shape once again helps the boat travel at higher speeds. The slanted front and back allows more of the boat to be submerged underwater compared to if the front and back sloped vertically up. This increases the water displacement to increase the force of buoyancy, since the force of buoyancy is calculated by F equals the density of the fluid times the volume submerged or displaced times gravity.
We're not even supposed to be rapping. We're just trying to be creative. After boat number 1, we ordered some pizza. We took a break to eat lunch. We also changed our prototype. In prototype number 2, we increased the depth. In boat number 1, the depth to width was about 1 to 4. In boat number 2, we changed it to 1 to 3. We also decided to add wings to the side. In order to make these, it was similar to the boat, just narrower. However, it didn't work very well because the supports were very weak. This boat in the middle dragged down the wings on the side. It didn't float very well. We need to add more support.
Our second prototype was more ambitious. It kinda looks like Moana's boat, but it essentially has a multi-hull design. The centerpiece is similar to our first prototype, except with a narrower design and a deeper V-cut on the bottom, as we discovered that the V was too shallow on the first one. We hoped that this would allow the boat to cut through the water even easier. The hulls on the side of the boat serve to provide extra stability. The side hulls sport a similar design to the hull on the centerpiece. They too use a V-cut, but they are raised slightly higher than the middle hull by the support beams. After our first test of the second prototype, we found that with added weight, the two hulls on the sides began to slowly collapse inwards, so we used right triangles taped on top of the hulls to make it more sturdy.
So, what we learned from building our boat prototypes and testing them out is that we wanted an angled bottom for the hull because it seemed to balance pretty well while still cutting through the water because this is a boat race. And we also wanted sharp angles at the front and back of our boat because again, it traveled through the water sufficiently. But one of the biggest improvements that we can make upon our boat is adding more structural support, which I noticed for the first prototype, the regular boat. The real time when it started sinking was when the side was when we put too much weight into the boat and the side started caving in, making the height of the walls less and allowing water to finally get in. And then also with our second prototype, the winged design, the sides that were the wings that were holding onto the sides that allowed for more balance with the boat so that it wouldn't tip over as easy were not sufficiently supported so that the boat, the central boat piece, would stay at level with the wings, making it so that the central boat would get lower than the wings, and so the wings didn't really help as much as they could have in keeping it balanced. And so this is what we learned from building our boats.